Today, he will be sharing exciting new discoveries about water, showing that it's far more than just water. So get ready to witness a live demonstration and discover the fascinating behavior of life's most essential molecule. Welcome, Nikolaj.
Thank you, Louise. And thank you to all of you brave souls who are sitting inside in this lovely weather. I was so fortunate to be outside all day yesterday, but I would really have loved to be here. It's such a fantastic venue, and the topics are so exciting. So I really look forward to talking about water in the next 20 minutes or so. And I've been giving, I must say, the title structured water because that's what many people talk about these days. It's not my favorite term, and I will come back to that. But I've decided to use that term anyway. So what is this about water? Isn't it just these random H2O molecules that we all learned in school, just swimming around chaotically? Maybe not. This is an image from, as you can see, it's an iceberg. I just came back from Greenland recently with a great crew. We were up studying a sacred mineral spring in Greenland. So technically, fundamentally, you could say, yes, structured water exists right there. This is structured water. This is an iceberg. Ice is structured water. But I guess what you are curious about is, can liquid water also have some kind of structure or organization? My name is Nikolaj. I have a career background from DTU as a scientist, DNA researcher. DTU is a technical university. And I have a fondness for the Arctic and Arctic expeditions and so on. So I just came back from an event yesterday that prevented me from being here. So it was a tough choice, but I was at the Youth Island in Øresund, celebrating the UN Peace Day yesterday with scientists, other biohackers, I would say, shamans, and a lot of great people just like you. So I'm here today with a lot of inspiration from this event, surrounded by water. But the topic was also quite serious. It was about peace. We don't have that much peace in the world right now, or at least we have many places where we don't have peace. But I think that the take-home message from that event was that first we need to find the inner peace. And perhaps water can be an inspiration to doing that. So at least that has been my experience. That studying water, getting acquainted with water, having a relationship to water can help you find this inner peace, which is necessary to create outer peace in the world. And one of my heroes has one of my favorite quotes here. Anyone who can solve the problems of water will be worthy of 2 Nobel Prizes, one for peace and one for science. And I really do believe that that's true. So let's dive into it. I think studying water makes you wonder, maybe makes you remember when you were a kid and you looked at soap bubbles and wondered why do they have the colors of the rainbow? Why do they float? Why don't they just disappear? Sometimes they do, I know. But as I said, water is more than just H2O molecules, and I will in a short while show you a little video explaining that. So here's an overview slide of what sums up my career, I would say. I have a nose for the next big thing. First it was bioinformatics, then what was microbiomics, and now I'm really, really passionate and curious about water and what we can learn from water and what technologies can emerge, but also our own relationship to water. So I'm going to show you this little video. Hope it works and hope you get the sound. I'm looking at the tech guys.
Without water, no life. biological life has emerged in water. Our lives depend on it. We are even mostly water ourselves. But there's a lot we still don't know about water. Based on my research in water, I think we are on the brink of discovering water as a new source of energy or medical treatment. I just need to find the key to unlock water and its hidden potential. According to traditional science, water is a simple molecule with a simple behavior. But in my laboratory, I observe how water molecules can be forced to act in a way that actually changes the physical properties of water itself. Take, for example, the experiment, the floating water bridge. When I expose 2 glasses of absolutely pure water to a high electrical field, the water molecules are forced to connect and form a rope-like structure that is able to hold its own weight in free air. This opens up for a whole new understanding of the potential of water. But so far, science cannot explain. I cannot explain why water acts like this. That's why I, together with some of my colleagues here at DTU, are searching for the proper measuring tool. Maybe even to be found in our own backyard or used in previous science projects. A tool that can unlock the mystery, decipher and measure what I now can only observe. It's like trying to find the thermometer, enabling us to tell the temperature of a substance. I'm sure my quest will be met with a lot more obstacles along the way. But I will keep on going, because my work will maybe lead to a new scientific paradigm that will shift the future of planet Earth and its inhabitants, simply by exploring the most basic molecule of life, water.
So this experiment that you saw on the video, I was maybe stupid, maybe bold enough to tell the organizers that I would bring it to give you a live presentation today. So at the end of the presentation, I hope that I can demonstrate it to you live. And for those really interested, I think you need to come closer, but we also have a video crew that will see if we can display it. So this experiment was first performed late 1800s, so 130 years ago, and then it was kind of forgotten. And some scientists rediscovered the old articles and papers like 20 years ago and said, wow, what is this? What's going on? And today it's considered as, if some of you are familiar with the double slit experiment in quantum biology, some of you are nodding. I would say this is the same type of really paradoxical experiment that we cannot explain really what's going on. But we can see it with our own eyes. So clearly there's something going on. Clearly water is changing its structure, its organization, and so on. But we can talk much more about that when I show the live demonstration. Perhaps you've also come across some of these people like Masaru Emoto, Japanese researcher, who unfortunately passed away 10 years ago, but he made these beautiful images of ice crystals that had been exposed either to loving thoughts and gratitude or to, let's say, more negative hate speech, we would call it today. And he observed that the water that had received love and gratitude produced these beautiful crystals, and the other water was pretty ugly, the crystals that came out of that. If you're curious about his work, you should also look into Veda Austin. She is a woman from New Zealand taking his work to the next level, I would say. So look into Veda Austin. She can literally communicate with water, I would say. It sounds crazy, but it seems like she can. Also look into John Stuart Reid. He has a beautiful setup to photograph and film what's called cymatic patterns in water. So he's playing sound to water and then he's visualizing it, and it produces these beautiful images. I won't have time to go much into it, but it's really a beautiful universe that he's creating. And somehow there must be some kind of water organization behind it, some structure. And now coming to the elephant in the room, what is structured water? And I think for me, the best metaphor analogy for that is, maybe you know the story of the 6 blind men who are sent out by the king to describe an elephant. And of course, it depends on what they grab onto. They will come back with different answers. And this is basically how I see what is structured water today. And we have several frontier, high-level scientists, Nobel-class scientists, I would say, that I wouldn't say they're grabbing onto the tail or the trunk, but at least they have different point of views of describing water. One of them is a professor in Stockholm, Anders Nilsson, and he says water is actually 2 liquids disguised as one. That's his slogan. Anders Nilsson received the Ørsted Prize at DTU a few years back, and he has some cool discoveries about what he calls low-density and high-density liquid water. Gerald Pollack is also a well-known figure in this field. He holds the annual water conference and has this description of water as the 4th phase of liquid water, which is more like a liquid crystal phase. He also calls it EZ or EZ water for exclusion zone. And here you can see that, I guess you need to know what we're talking about, but you can see a vertical line, which is like a membrane. And on the right side, you have water plus some small plastic particles, and they're pushed away. So there's a zone next to the membrane where water is pushing away, excluding particles. And that's a zone that has a different organization, different structure. I think that the really cool guys, in my view, are some of these Italian professors. Unfortunately, they both passed away. But they're talking about quantum electrodynamics. So they have a full framework of explaining what are quantum effects in water and how could it be that the water is such a mysterious, anomalous molecule. Coherent domains means that we're talking about coherence. And coherence is a phenomenon that we know from different materials, phenomena. And I would say it gives superpowers. In the case of light, you can see here sunlight is kind of a random mixture of different wavelengths. LED is only one color, one wavelength, but they are not in sync. But if you make them, the light particles, the photons, work in sync, you get a very powerful light like this laser here. And we all know that has a different quality to it. It's almost like it has a superpower. Perhaps it's the same with water. That water can be what we call quantum coherent. We found it in the laser. We found it in a form of carbon called graphene, which is super hot topic. The strongest material in the world. It has a lot of superpower abilities. So it's a good guess that the water could also have these superpowers of being coherent. And this leads me into what I call quantum biology. So when I studied biochemistry, I mainly learned about molecules and particles, and I basically didn't learn anything about the wave aspect of biology. And this is why I use this term, quantum biology. So to quote my name brother here, Nikola Tesla, if you want to find the secrets of the universe, think in terms of energy, vibration, and frequency. And if you want to have the link to biology, I suggest you look up this wonderful music professor on his TED Talk, where he demonstrates that he can actually he can activate, or he can stimulate certain bacteria or viruses with a certain frequency of electromagnetic fields. So he actually inspired me with this, some of these findings here to set up an experiment and apply for funding. And another way of seeing this is that what if we, being mainly water beings, could it be that we are basically liquid crystal beings, and that we can be affected by electromagnetic fields in certain ways? That's the theory behind these new medical treatments. Here's one of the pioneers who was, unfortunately, he was forgotten. He lived 100 years ago, Royal Rife. He invented a lot of fantastic technology, microscopes, and devices who could treat different bacteria and infections and so on. I was inspired by both this Anthony Holland and Rife, and applied to the Willem Foundation a few years ago and got a grant from there. And the idea was to see if we could inhibit bacteria that would normally be treated with antibiotics, but with using electromagnetic frequencies of a certain resonance. So the principle being, as you can see here, maybe you heard about an opera singer who can find the right tune and make a crystal glass explode. I don't think most of us can do that. I don't even think there's enough energy in a voice, even from an opera singer, to shatter a glass, but still it happens, right? So it's a matter of building up the energy and utilizing the resonance effect. So yeah, we spent a lot of time just figuring out how could we build a lab to investigate this, because as you all know, we are surrounded by electromagnetic fields all over, mobile phones and television and so on. So we had to build up this shielded lab at DTU, and we found these very preliminary findings that we could inhibit these bacteria, which are growing in the lungs of cystic fibrosis patients called Pseudomonas, by about 40%, just by this very basic, very preliminary setup. So that was very, you could say, encouraging for us to see that we could do that. And this led me to, I was a little bit in doubt if I should share my personal story about this today, but here I am, I'm sharing it. And a few years ago, I went to the doctor with a lot of pain in my hip and my leg. And I found out that I had arthritis, slidgigt in Danish, in my hip joint. And my doctor said, well, aren't you a bit too young for that? And what have you been doing? And I said, well, I don't know. I guess maybe I had been too stressed and it was an inflammation reaction, I don't know. Anyways, and it's not to put down our healthcare system, but he sent me to some simple gymnastics and some scannings. And he said, well, just, try to bear with the pain as long as you can, and then you can get a surgery and a hip joint replacement, and hopefully you will be fine. But I didn't feel that didn't feel right to me. So I started looking for another type of exercise that wouldn't put so much pressure on my joint. I found one called reformer Pilates. Maybe some of you know it, with what's called spring loading, and so that helped a lot. And then I found this Rife technology that I've been using as the basis of my research projects, but I never connected the two dots that I could use it on my own body. But I went to a former professor at DTU who had been turned into a holistic practitioner, and she said, "Well, yes, this has been forgotten, but it works. So let's check your body." And she came up with, she found that I had a massive Pseudomonas infection in my hip. So she recommended both antibiotics, of course, what a normal doctor would say, but also this Rife technology. So I got some frequency treatment, and it was just magical. After a few days, I would say it went from, if the pain was 10, it went to 4 in a few days. So that was amazing, and I'm still a little bit shocked about that this technology is not being used more in society. I don't know if there are anyone here working with Rife or frequency medicine, but I think that would be there's definitely some potential there. Another thing that I found in my search was shockwave, ultrasound waves that are used in the healthcare system. For example, if you have a kidney stone, you can break the stone with ultrasound from the outside. But it's not used for joint problems, and it actually, oftentimes you have small, what's called calcifications in your joints, meaning that it's like you have it. It moves in steps, and it's like throwing gravel into a machine, and it doesn't feel good. So you can actually remove that with this shockwave ultrasound. And then, last but not least, I found that being kind to my body and giving myself kindness and gratitude. Maybe that's the most important factor in healing yourself, actually, and I think also other people have talked about that the power of the mind, the power of compassion and healing. So some of you will probably also wonder, hey, how can I structure water if it's all these different ways? And some of them I mentioned here. And if you ask me which one do I recommend, I'm sorry, I don't have an answer for that. But vortexing, which means whirling the water, ultrasound, certain surfaces, information water I write here. Some of you maybe heard about Grander water from Austria, and also certain electromagnetic fields can structure water. It's just some of my, just a few selected inventors. One is from Denmark, one is from Sweden, that are working on this. So I think I'm nearing the end here, and I would like to leave a few minutes for questions. So I think if you're in this kind of science and this kind of area, you need to be brave and take risks, and then you need to trust your experience. What do you see in the experiments? So what's next? Well, my dream would be to have a new kind of research institution, knowledge institution, where you don't have to have a scientific degree to enter. You just need to have a good idea, and to be able to argue that you have observed something, because I don't think that we solve the big global projects by just giving, a certain discipline large grants. I think this is a collective task we need to solve. And this is my last slide. So thank you for your attention so far, and
and we have time for a couple of questions.
Good. Then I put on
yes,
this.
we have one here,
Yeah.
Olivia. But you need a mic. 2 seconds, and you need to put those on. Yeah, super. Okay.
Thank you so much for your talk. I practice as a medical doctor, the electromagnetic stuff. You're gonna love this.
Yeah.
Bone and collagen is piezoelectric. And what that means is that bone and collagen converts mechanical pressures into electrical signals. And so
I get goosebumps. So
yeah, we need to talk.
We're building bridges here. Super.
Yes,
Thank
exactly.
you. Other questions? Yes, we have one down there.
Thank you for your talk. My question is, with the potential of water bridging, there's been frequency used in therapy for quite some time. But with this particular one you just showed us, what do you think that in your view, the practical uses of it will be first and foremost? Because I think right now at this point I'm like, okay, cool trick, but what would we use it for?
Good question.
You mean the water bridge experiment?
Mm-hmm.
Okay. I think this is an eye-opener first and foremost to get us to widen our imagination. But it also, I mean, it may sound like a cool trick, but if you think about it, and you calculate the strength of the field and so on, it's 1 million volts per meter that I'm going to put on here. I'm not going to use 1 million volts because it's only 1 centimeter. But if you look at a cell membrane, which is a few nanometers thick, and you know that it's maybe 100 millivolts electrical potential across, it's also 1 million volts per meter in our cells. So this is what's actually going on across our membranes in the cell. For example, the aquaporin molecules.
Can I continue my question? Okay, so in the video that you showed us, if I remember correctly, the water was pure water, correct?
Yeah.
So could this actually be used to draw pure water out of the ocean as well?
If you ask me, yes. But I haven't seen it yet. But yeah.
Okay, super. Thank you very much. Should we see the demonstration now?
Let's see it.
And we're doing with the camera, right? And people can see it on the screens.
Hopefully.
Or you think we should actually get? We are a lot here. I don't know if we can all be here.
Shall we start with the?
We start here.
With the video, and then those
and hopefully people can get up and see you afterwards.
So. And those of you who are interested, you can see that if you look at this display, it will say maybe 9 or 10. That means 9 or 10,000 volts. So you know that's a lot. But don't worry, we have very low amps, so it won't kill me or you. But I still wear gloves. Turn it on here. It says 5,000, and it's very wobbly. So I touched the wrong glass now. I just got a little shock. So I need to, they need to kiss first, as on every proper date. So, and let's see. You know, I'm gonna switch it around because normally I use my left hand. It's interesting if it doesn't work. It worked yesterday on the youth island.
We believe you.
So, yeah, it's very thin, but it's there. Can you see it on the video?
Yes.
So we're almost up to 1 centimeter. And for those of you who wonder, is there transport from A to B or from B to A? The answer is both. So water molecules are transported from one beaker to the other and back again. And if you have really sharp eyes, which I don't, then you can see that it's actually 2 spirals going in opposite directions. Which reminds me of my other favorite molecule, you know, 2 helices going in opposite direction. The DNA molecule.
It's really amazing.
Should we invite
Let's
people?
give him a hand. Woo!